All right. So once again, for the sake of video, I will repeat myself. Every question that we do, I will sort of set us up to go from words to a mathematical equation. The solving you can do on your own by checking my answer key and then whatever. All right. Please note, anytime it's a form of a word question, typically, most of the time, it will be in the application category, right? Because it's not a simple mathematical equation. It is using your knowledge for a different scenario. A set of measuring spoons contains spoons for fractions of a teaspoon, which is true. If you've ever baked, ever cooked, ever done any form of measurement in the kitchen, you realize baking is actually a science. Surprise. These spoons have the following labels: quarter, half, and eighth. Which of these spoons will hold the most? Which of these spoons hold the least? Use a visual representation to support your answer. Well, because I'm trying to deliver a math lesson, I'm going to pretend this is my spoon. Okay. A half is this. Make sense? A quarter is that. So it's half of a half. An eighth is this, which is a half of a half of a half. So which one holds the least or holds the most? Half is largest. 1/8 is smallest. So it holds the least. Very simple. How many scoops from the smallest spoon are needed to equal 1 scoop from the largest spoon? How would you set it up? Visually, you can probably calculate that. Mathematically, so again, visually, right? This is, I need 1, I need 2, I need 3, I need 4, right? I need 4 of the 1/8 spoons to make it equal the half spoon. Mathematically, take a look. You can make it look like this. If my slice, if my piece was broken, if my spoon was broken into pieces of 8, how many, so this is a big question mark, big X, how many of these will equal 1 if I broke the spoon into a half? Yeah, right? So essentially it's like, okay, so I have 1/2. If I wanted to turn it into an 8, what do I have to multiply? 4. That means my X value must be 8. Right? There's a lot of different ways you can talk about this. If you don't like that, you can also talk about it as, okay, if I have 1/8, how many of these do I need to add to get to 1/2? You can do that way. Is there another way? If you can represent this in an addition way, we can also represent this in a subtraction way. Is there a way we can present this as a subtraction? Here? Yeah, you can do, okay, so if I have this and I took away 1/8, how much is left? Okay, now that I figured that out, I'm going to take that same value and subtract by another 1/8. How much is left? Okay, I'm going to take that value, so continue subtracting by 1/8 until I have none left. There's so many ways you can communicate it, but I will leave that again to you. All right, there are going to be questions like this, and how you describe it is your choice because you are applying whatever math knowledge you know. I want to know how you think, not just memorize math the way I taught you. You have to be able to use the language. Here we go. Example, another one you can do. Of the students in a class, this is important, 3/4 take the bus to school. 3/16 of the students in the class walk, and the remains are driven to school. What fraction of the class is driven to school? I can do this as an addition. I could do this as a subtraction. Miles, do you have a choice? Do you have a choice? Would you rather do addition or subtraction? Addition or subtraction? You can just choose. You can do it either way. You want to add or subtract? Addition. Sorry, I can't hear. Maybe this is an echo. So of the students in the class, I'm going to have 3 out of the 4 students by bus. And let's add that with 3 out of the 16th of the class walking. And the remaining fraction is going to be driven, so car. What is that fraction? Well, know that if I added it all together, I am going to have a full 100%. In other words, I'm going to have a total of 1. So since I'm already here, okay, how about we do it this way? Let's pretend that if I break the class down into 16 students, well, I'll have all 16 adding together, right? Because this all has to equal to 100%. That's it. So let's first add this up to see how many students are left. We've got, let's see, multiply by 4, 12 over 16, 3 over 16, plus, you know what? Let's add that up first. We have 15 over 16. Therefore, out of 16 over 16, if I take away the 15 over 16, I have this. Oh, big whoop if you understand how to add or subtract fractions. Application questions will ask, do you know when to apply either or? So I'll read through this and see if you recognize, if you can grasp the logic. The entire class is going to be 100%. 16 over 16. I have 3 out of the 4, 3/4 going to bus, and 3/16 going to walk. How many people are left when we are going by car? So I changed everything to have a denominator of 16, and I found that out of 16, 15, or out of a class, 15/16 of the students are going to be either busing or walking, which means whatever is left over, subtraction, is going to be walking. Guaranteed, if I gave it to you in normal numbers, you would be able to add and subtract. But since it's fractions, you might start getting tripped up simply because you're not used to using that normally. Yes. Oh, yes. Of the class, go by car. Sorry, only 1/16 of the class go by car. Okay, or are driven. It's probably the more efficient way to do it. Okay, let's keep moving. There's really nothing here that should be particularly groundbreaking. But if you take a look at all the questions from that question on, it's just adding, subtracting, multiplying, dividing. It's all that stuff. Here's more complicated situations. Here's more complicated situations. So I think what I would do is, let's do one of the questions here, just to remind you how to add. Let's do one of the questions here, for example, just to remind you how to divide. And then maybe we'll do one of the hard EdMass ones together in preparation for the future. The rest of class is yours. Sounds good? Yeah? People dying inside? Oh, super quiet. A little more quiet than usual today. All right, here we go. Reminder of how to add or subtract. Step 1, let us try, I'll write it here. Can you simplify the signs? You know what? I am going to. I have an addition of a negative number. So positive, if I were to multiply this out, because we have a +1 multiplying to a bracket, this can be rewritten as just like that. I don't need that bracket there. It doesn't serve a purpose. Next, if you remember, we don't deal with mixed anymore. Let's turn it into an improper. 3 times 5 plus the extra 4 pieces. This is 19/5. 1 times 10, add that to the extra 7 pieces. This would be 17/10. Some people might be confused. Oh, Mr. Kim, is the top number supposed to be negative? Is the bottom number supposed to be negative? Are they both supposed to be negative? Don't concern yourself too much. If you must choose, I think it's at this point in time, it might be easier to assume that the numerator is negative. The real answer is one or the other can be negative. You get the same result. That could be confusing to some of you who are still grasping. So just assume that work the denominator as you normally do and simply add or subtract the numerator as you see fit. We have the same denominator, so multiply by 2/2, which means 38 minus 17, 21. Done. Yes. No. So I'll put this thing here. Improper fractions.
Is it negative or positive?
Is going to be positive. The 38 is has a larger number of pieces. You're taking away 17 pieces from it. Okay, and now right here, leave as improper. Remember, from this point on, you never have to deal with mixed again. Even in our assignment on Thursday, remember I show you how you need to bring it in terms of feet and inches. Okay. When you get it when you're going to write it down as a mix, I'm going to force you to turn into an improper. Let's go to the very last question, letter F, and I will show you how to remind you how to do a division. Remember, once again, I do not want to deal with that. Please turn it into an improper, which is a 4 times 3, that's a 12. adding to the two pieces I already have. 3 times 5 is a 15. Add it to the pieces I already have. There we go. And when you are dividing, it's the same as multiplying a reciprocal. I wish there were numbers I can divide out, but I do not have it. There, you're done. Okay, so I'll write here. How about I write multiply reciprocal. And then here, I'll just say multiply across as an extra hint. Yes, Evan. A reciprocal is basically a fraction where the numerator and the denominator have switched places. They flip upside down. So remember, this is a 19 over 5. It became a 5 over 19. Maybe should I color code that? Maybe. I'll do it like that. Okay. I'm going to spend the class time doing the rest of these examples. I will do one more, and that's like what I think is one of the harder ones on the next page. If you turn the page, you will see example that says use BEDMAS, 2 fractions or 3 fractions adding, subtracting. I have a bunch of fractions subtracting and dividing. I have a whole bunch of BEDMAS stuff, and then I have just a regular exponent. I'll let you choose. Would you like to do B or C? Oh, wow. Okay. I think you say C because it just looks a little bit more complicated, but we'll go through it little by little. Starting with BEDMAS. I would like to do BEDMAS, but let's be honest, mixed fractions, I don't like. So I'm going to highlight it once again. At this point in time, I'm hoping it's rote memory. You've just turned it into muscle memory. As soon as you see it, you're like, okay, change it first before I do anything. Change it first before I do anything. Change it. You get it. Okay. Let's move on. Brackets. I got to deal with this, which means I need the same denominator. If you are good, you can probably do the multiplication and the subtraction all in one step. I'm not going to do that for now, but if you've done enough of these subtractions, you will be tired of it and you'll be looking for ways to shortcut yourself. Right? You'll be looking for ways to cheat and get faster. That is the result of mathematicians being lazy because they've all gone through it. The most brilliant of mathematicians, they've done this so many times and just like, they're like, I'm sick of this. I already know it. I don't need to show work. And it looks like they're skipping steps, but other mathematicians who've gone through the same thing, they're like, I know exactly what you did. They sort of laugh at themselves because they understand. Get there. Practice your butt off until you develop your own shortcuts. This is a 12 with a 21. This becomes a 12 with an 80. Let's keep going. I still have to deal with a bracket. So that becomes negative 59 over 12 squared. All right. Whoa, it's going to be a big number. Let's keep going. After brackets, since there's nothing else to simplify, I'm going to do exponents. Negative times a negative is a positive. 59 times itself, I don't know that off the top of my head. So what? 3,400. Yeah, that sounds about right. And then 12 squared is 144. And let's do this exponent as well. 25 over 36. Please notice, by now, this shouldn't be a question. You shouldn't be multiplying the 1 over 3 inside first. That's not what's supposed to happen. By BEDMAS, the exponent happens before that. Here, we can start working through. Now, do I have to do it that way? 3, 3, 1, 18. Oh yeah, it's not divisible. Okay. Then 3 times 144, 432. Pardon? Is there a reason why the line is so big? This part? Yeah. I just knew it was going to be a large number. So I just drew it ahead of time. Yes, Evan. Because when you're multiplying, the numerators and the denominators will multiply across. Good. Okay. And now it's an addition subtraction question, but yeah, the denominators don't look good. I'll give you a hint. Well, at least rather I'll do it for you. It's actually a multiplication of a 1, that is 12 over 12. Hang in there, this is the last one I'm doing for you. 25 times 12 is 300. So the final answer, I wonder if I have to reduce. Negative 3481 plus 300 is negative 3181. At this point, I can't divide by a 2. Can I divide by a 3? Nope. 4 doesn't work. 5 doesn't work. 6 would work. 6, 6, no, doesn't work. 7 doesn't work. 8. 8. Nope, doesn't work. 9. 9. 3181 divided by 9. Nope. I don't think any of the, I don't think we can reduce it. I think we're done. So quick recap of that hardest one. It's long and it's annoying, but it's not anything new. I first made everything into improper fractions. I then worked out BEDMAS by solving the bracket, and then the exponent, and then I multiplied, and then I added BEDMAS. That's it. If you want a specific tip in preparing for Thursday's class, I want to recommend doing all of the word questions and seeing if you can set it up correctly. Forget the right answer. Are you understanding the assignment here? Are you understanding what they're asking for? And are you turning it into a proper mathematical statement? Okay, practice that. This answer key, I'm going to put it up as a PDF in our Google Classroom. And yeah, the rest of class is yours to practice, and I will leave that responsibility for yourself. Absolutely. You can go. Any questions? All right, let's get to it.